Hello, 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 and welcome back to Shiksha DaCosta. Today we're going to learn how to graph a quadratic function when it's in vertex form. As part of this lesson, you are going to learn how to sketch a graph of a quadratic, and you're going to do that by applying one or more transformations to the graph of the parent function f of x equals x squared.
To start off, I'll ask you this question. This point is on y equals x squared, and it's been transformed onto this new quadratic. Can you list all the things that have happened to the parent quadratic to transform it into this new quadratic? So the first transformation we're going to look at, we'll just go left to right, okay? We'll start with the a value. The a value here is -3. That's always going to be in front of the brackets. Okay? When the a value is a big number, there's a vertical stretch. When it's a negative number, there's a reflection in the x-axis. The next one we're going to look at, again, we're just going to go left to right, is the h value. The h value is +4, and it's moving to the right by 4 units. The last value is k. K is 10, and that means that the function is moving 10 units upwards. Easy enough, right? Now let's get to this point, 2, 4. Where is its new location? Well, we know that h will affect the x value, but there's a problem, because in 2 lessons ago we learned that a affects the y value, and we also learned that k affects the y value in the previous lesson. So if both of them affect the y value, which one do we do first? Do we multiply by -3 first? Or do we add 10 first? What do you think? The value that comes first will of course be a, because we still follow BEDMAS, right? When we have to follow our order of operations when we're applying them, and multiplication happens before addition. So I'll still start off with my point like usual. And the h value, yes, that will affect x. So x will go up by 4. 2 will increase by 4 to get 6. 2 plus 4 is 6. But what happens to the y value? The first thing I'll do is multiply it by -3, and then I will add 10. So 4 times -3 is -12. -12 plus 10 is -2. And that is my new location. So again, just to recap, I started off by listing my transformations, and then I took the point 2, 4, and I applied those transformations to find out its new location. That's all I did. So today's lesson is using transformations to do this to not just a single point, but an entire quadratic. Now, we're going to learn a few ways to graph this quadratic. The first way is going to be the longest way. It's going to break it down step by step, and then we'll try and speed it up, because I don't want you spending so much time on this. Okay? This is the quadratic y equals x squared, your basic parent quadratic. The a value here is -3. The h value is 4. The k value is 10. This is the same quadratic we just looked at. Okay, but now we're going to graph all of the points, find out all of their new locations. The first thing I'm going to deal with is the x values. So all of the x values increase by 4, because h is the only variable that affects x. A and k, they affect the y coordinates. So these are my current x values and y values. I'm going to graph a new quadratic, and I'm going to do it in red so you'll see it. And all of my x values will increase by 4. -3 plus 4 is 1. -2 plus 4 is 2. -1 plus 4 is 3. 0 plus 4 is 4. And so on, and so on, and so on. So now I have all my new x values, and I'm going to see where is this quadratic going to end up being. All of these points will move to the right 4 units. And that's my new location. Let's check if my new coordinates are correct. 1 and 9, yep. 2 and 4, yep. 3 and 1, yep. 4 and 0, 5 and 1, 6 and 4, 7 and 9. All of those are correct. Now let's deal with the y values. So again, we're starting off with the red quadratic. And I'm going to apply a first, and then I'll apply k. I'll multiply them all by -3. So I'll take all my y values and multiply them by -3. And these are my new y values. So all of these this quadratic got stretched vertically first. And then it got reflected. It was upside down. All of the y values became negative. And the last thing I'll do, I will deal with the vertical shift. So all the y values that I have, they will increase by 10. So I'll just add 10 to all of them. And that will make all of the points go up 10 units to here. Just like that. And there we go. I've applied all my transformations. That is my quadratic in its final form, fully graphed. This is the long way to do it, to make a table of values for each transformation, one step at a time. It doesn't take so long, but who wants to make 4 different tables? You know, that can be a little annoying. So instead, I'm going to show you one more, a little bit faster way to do it. Then we'll summarize the lesson, and I'll show you probably the fastest way to do it right after that, and then I'll give you some time to practice. So let's start again. Let's use transformations to graph this, but instead of dealing with x first, remember in the previous lesson, we learned that we can apply h and k at the same time? So why don't I deal with a first, and then I'll apply h and k together. So this is my quadratic. And I'm going to multiply all the y values by -3, like I mentioned. So here is my quadratic, and it's going to stretch, and it's going to reflect. So I'll first sketch out my quadratic with only a applied. And then I'll just look at every single point, and I'll apply h and k at the same time. So every point will go 4 units to the right, 10 units up. 4 units to the right, 10 units up. 4 units to the right, 10 units up. And there we go. Wasn't that much faster? We didn't have to make all of these tables. We only had to make one new table for the a value transformation. And then we just applied what we knew was going to happen to all of these points. So, to summarize this lesson, when compared with the parent function y equals x squared, the graph in vertex form, y equals a times x minus h all squared plus k, that is a parabola that has been stretched or compressed by a factor of a. It has been translated horizontally by h, and it has been translated vertically by k. As well, if the a value is a negative number, if it's less than 0, this parabola is reflected in the x-axis. It opens downwards. The vertex of a parabola, when you look at the vertex, this is called vertex form. And the reason it's called vertex form, obviously, is you can look at it and say, oh, the vertex is hk. No calculations necessary. Super easy to pull the vertex when you're looking at vertex form. The axis of symmetry, even easier. All you need is the h value. The axis of symmetry will always be x equals h. To find the new location for any point, all you have to do is follow the order of operations. So you're going to start off with a point. You will add h to the x value. to the y value, you will multiply it by a and add k, and that will be your new point. Okay. And this is probably the fastest way to do it, though. This example, we're going to go through it much faster. I'm going to sketch the graph without using transformations. So this is my parent quadratic. The first thing I'm going to do is look at where is my vertex going to be. And I know it's going to be at hk, 4, and 10. That's my vertex. So I'll plot my vertex out right away. I know that's where it's going to end up. To really sketch a quadratic, all I have to do is really connect the dots. But I only have one dot here. I'm going to look for at least 2 more dots. And I can pick any x value that I really want, as long as like it's pretty close to this. So I'm going to pick an x value. This x value is 4. So I'm going to pick an x value that's kind of close. Maybe I'll pick 6. So I'm going to plug in x equals 6, which is just 2 units to the right of my vertex. And you can pick whatever point you want here. And I'm going to take that value and plug it into my parabola, and that tells me the y value. So when I plug in 6, I get negative 2. So there must be another point down here at 6 and negative 2. I know the axis of symmetry goes right through the vertex at x equals 4. And the reason it's called the axis of symmetry is because if there's a point here that's 2 units away, then there will be another point here, also 2 units on the left side. That's what symmetry is. This is like a mirror for every single point on the parabola. So I've plotted my vertex. I've plotted one other point. I've used the symmetry to plot where it would be on the other side of the axis of symmetry. And now I just connect these with a smooth curve. And that's about all you need to graph a parabola. It's a vertex and like a couple of other points that are symmetrical. This was a lot faster than doing all the transformations. But if you prefer to do the transformations step by step, if you prefer strategy 1 or strategy 2 or this one, this is strategy 3, whichever works for you, at the end of the day, you will get the right parabola. Okay? But just make sure that you are following the steps in the transformations in the order, and you should end up with the same answer no matter which strategy you pick. Remember, when you're graphing a quadratic like this, the vertex is always the most important point to graph, right? That tells you where the tip of the parabola is. The other 2 points don't really matter at all. You can pick any points on the parabola. I like to pick some that are pretty close to the vertex, just so that I don't end up, falling off the graph, because the y values can vary pretty dramatically.
If you like this video, please like, rate, subscribe, and join our mailing list. And you can find this lesson as well as practice questions, solutions, handouts, and more on our storefront. Thanks and have a great day.